Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about the measures of a central tendency of a data set. Previously, we learned how to make the analysis of a data set pictographically using the various type of the graphs. For example, using the histogram or the steam plot in order to understand the distribution of the points, or using the scatter plot in order to understand the correlation between the two things, for example, the temperature and the sales of ice cream. Well, today we are going to learn how we can measure the central tendency using one number numerically. Before we do this, we are going to introduce the notation of a numbers in the data set. So we are going to denote all of these numbers using x1, x2, and so on, xn. For example, if you've got a sample with 5 numbers in 5, 4, 3, 2, 10, then we are going to say that x1 is equal to the 5, x2 is equal to the 4, x3 is equal to the 3, x4 is equal to the 2, and x5 is equal to the 10, when 5 is going to be the number of the values in your sample, or simply the sample size. Well, the mean or the arithmetic mean is one of the popular ways to measure the central tendency or the center of a data set, when we are going to simply add all of the values of your sample and divide this simply to the sample size. So, but at the same time, another measure of the central tendency is called the median, when we are going to take the middlemost value of your sample when all of the values are arranged, are sorted by ascending or descending order. So let's evaluate the median and the mean for this set in order to understand how it works. So the mean is denoted as the x bar. So we wrote this as the x bar is equal to the sum of all of these values, 15, 14, plus 2, plus 27, plus 13, over 5. So if we sum this, it is going to be 31 plus 40 divided to the 5, and that's going to be equal to 6 plus 8, 14.2. At the same time, the median can be found when we are going to sort, first of all, the data set. So essentially, I'm going to sort them in ascending order, in increasing order, 2, 13, 14, 15, and 27. And this number, which is exactly in the middle, is going to be the median of a data set. So you can see here that for this particular example, the mean and the median are very close. So what happens when the number of the values in a sample is even number? How to calculate the mean and the median? So the calculation of the mean is going to be done in the same way as we did before. It is going to be the sum of all of these values. It is going to be 11 plus 9 plus 17 plus 19 plus 4 plus 15 divided to the 6. So you have to use a calculator or some arithmetics in order to calculate this. It is going to be equal to the 20 plus 38 plus 17 divided to the 6. Then we can calculate this. And the median is going to be calculated when or found by just sorting, first of all, the data set. We're going to sort this in increasing order. So I'm just going to find the minimum value, then the second minimum value, then the third, 17, 19, or I forgot about 15, right? So 11, 15, 17, and 19. And you see here, the middle of this data set is going to be no number here, right? So the number of the values in this set is even. So in order to find the median of this data set, we're going to find the mean of these two values in the middle. So the median in this case is the mean of two middle values. So in this case, it is going to be 11 plus 15 over 2. And that's going to be equal to 26 over 2, which is equal to the 13. So when the values, the number of the values in your sample is even, then we have to find the mean of two middle points in order to find the median. Well, so usually we use the mean in order to calculate the central tendency of a data set because it basically includes all of the values of your sample in its calculations. So we say that the mean is more reliable. So essentially, when you are going to take a different samples from the same population, the values of the mean are going to be more or less the same. Okay, so essentially you take a sample from one sample or the two sample from the same population, and the first mean of the first sample is going to be close to the mean of a second sample. So we say that the mean is reliable. It includes all of the values of your sample in its calculation. But it is not resistant, and in this case, I would mean that it is not resistant to the outliers. So if you include outliers into your sample, then the value of the mean is going to dramatically change, while the median is more resistant to the outliers. The values of the median is not going to change if you're going to include the outliers to your set. So let's consider an example in order to explain what I mean. A small company employs 4 young engineers who earn 70,000 per year, and the owner, who is also an engineer, who is also going to work in this company, earns 160,000. Well, what is the mean and the median? So in order to find the mean, so we have to add all of the values. It is going to be 70 plus 70 plus 70 plus 70 plus 160 divided to the 5, and the mean is going to be equal to the $88,000 per year. And the median in this case, it is going to be when we are going to sort these 5 numbers in ascending or descending order. And then we're going to choose the value which is in the middle, which is 70. You see, so actually the mean is equal to the 88,000 per year doesn't reflect actually the typical value of a sample, right? So we know that typically the young engineers in this company earn 70,000, not 88. And the median in this case is more resistant to the outlier. So 160,000 is definitely an outlier. It is much more far away from the other values, and it dramatically changes the value of the mean from 70 to the 88, while the value of the median doesn't change by just adding this 160. So even without this 160, the median would be still 70. So depending on the different situations, we're going to use the mean or the median in order to find the central values. There is another measurement of a central tendency of a data set, which is called the mode. The mode of the data set is the most frequent values. In this case, for this sample, the 11 is going to be the mode. For this sample, the 11 is going to be the mode. So the mode is equal to the 11. So please note that the mode is not the number or the greatest frequency. So the greatest frequency for this set is equal to the 2, while the value with the greatest frequency is equal to the 11. So in reality, we don't usually use the mode for the numerical values or the data set with the quantitative data. So we usually use the mode for the qualitative data. For example, to know which color of the shirts have the greatest frequency in the class. So for example, the white one, and so on. So sometimes we are given the frequency tables and we need to validate the mean of a data set. So sometimes the points of your sample are not given. So they are already summarized as a frequency table. So well, this frequency table tells us that there are 5 values in your data set between 1 and 10, but I don't know what are the values, right? So they can be any value between 1 and 10. And there are 4 values between 11 and 20, but I don't know all of them. They might be like 4 appearances of the 11, or 4 appearances of the 12, or 4 appearances of the 20 even, right? So we don't know these values. Well, how to find a mean in this case? we can't really calculate the mean exactly for this case, but we can approximate this. So we can say here that the typical value of this class between 1 and 10 is equal to the midpoint. So the midpoint is going to be the typical value. So we usually say that this class is going to contain, so the midpoint is calculated by just adding the lower class limit to the upper class limit divided to the 2, which is going to be equal to the 5.5. So we say that I don't know the values here in this class, but I'm assuming that all of them are equal to the 5.5, and there are 5 appearances of the 5.5. It is going to be 5.5 times the 5. Okay. At the same time here, the typical value is going to be equal to the 15.5, and there are 4 appearances of the 15.5. There are 25.5, it's going to be typical value of this class, and there are 7 appearances of the 25.5. And 35.5, it's a typical value of this class, and 2 appearances of this number. So essentially, all of the values in this class are going to be taken as the midpoints. So since I know how many of them, I'm just going to find the sum of all of these values, right? So when I'm just going to sum all of these values, I'm going to get this number. And if you remember, in order to calculate the mean, we just need to divide everything to the number of the numbers. Well, how many numbers we have in the set? We have 5 of the 5.5, 4 of the 15.5, 7 of the 25.5, and 2 of the 35.5. So the total number of the values in the sample is equal to the 18. So we are going to calculate the mean using this formula. So by just multiplying the midpoints of every class to its frequency, and by just adding them, and by just dividing this to the sum of their frequencies, we can find the mean. So we are going to approximate the mean of a frequency table in this way. So using this formula, so when we are going to multiply each frequency to class midpoints and sum them and divide this to the sum of the frequencies. So please note that in this notation of the summation, I'm just neglecting this indices. I goes from 1 to the n for the simplicity. So whenever I write the summation, the sigma notation, you should already understand that it has the indices from 1 to the n. So from the first value until the end of the sample set. So we are going to calculate the mean. We are going to introduce something which is called a weighted mean now. So let's assume that a student has 90 from the homework assignments, 50 from the midterm, and 70 from the final assignment. So what's the grade of students for this course? So should I just so 90 out of 100, right? Out of 100, and 50 out of 100, and 70 out of 100, definitely. So what do you think? Should I just add this 90 to the 50 to the 70 and divide this to the 3 in order to find the grade? Or we should do something else? So if I would do this, that would assume that the homework is equally important than the midterm exam or the final exam. But usually it is not. Usually, so the homework assignments is the 20% of the grade, and the midterm exam is, let's assume that 30% of the grade, and the final exam is 50% of the grade, right? So this 70 obtained from the final is much more important, actually, this 90 taken from the homework, right? So in order to calculate the grade, I need to multiply those grades from the different categories to the weights of the categories, to the important indices of the categories. Well, in this case, I'm going to do this in this way. So I'm going to write down these percentages as a decimal form. So you know that 20% can be written as a 0.2, well, 30% can be written as 0.3, and a 50% can be written as 0.5. Well, I'm going to multiply the 90 to its weight. It is going to be 0.2 plus 50 obtained from the midterm is going to be multiplied to its weight, which is 0.3, and 70 obtained from the final is going to be multiplied to its weight. It's going to be equal to the 0.5. Then I'm just going to sum this. It is going to be equal to the 18 plus 30 plus 35. And if I sum this, it is going to be equal to the 75 plus 18, which is equal to the 93. Wow. So it's a really great, right? So you see, so I'm not just adding the three values. So please note that you can rewrite this formula in this way. So 90 times is a 1 over 3, plus 50 times is a 1 over 3, plus 70 times is a 1 over 3. So in the sense, the simple arithmetic mean is something as a weighted mean as well, when the weights of all of these three categories taken equally as a 1 over 3. But now we are taking them differently. So we're going to multiply 90 to its weight, 50 to its weight 0.3, and 70 to its weight. When the weights are different, then we're going to use something which is called a weighted mean. And the formula for the weighted mean is going to be very much similar to the formula of the frequencies. We're going to multiply the weights to the grades, and then we just divide this to the sum of the weights. So let's do an example. So let's calculate the grade point average of a student. So sometimes we call this as the GPA of a student. Student took 5 courses. Her final grades along with the number of the credits for each of the courses are given in the following table. So she took A from the first class for first course was the 3 credits, and 8 from the second class was 4 credits, B from the third class was 3 credits, C from the fourth class was 3 credits, and F from the last class. So we need to find the average grade. So where the values of each of the letter grades is given in this way. So A is 4, B is 3, C is 2, D is 1, and F is 0. So she took 4, 4, 3, 2, 0. Actually, right, from the following grades. So we can't really just take the mean, arithmetic mean of this 5 numbers in order to find her average, the grade point average, since the every point, every subject is weighted differently. So 4 credit is the most important subject, where it basically has lots of hours of the lecture, so that is why it is considered more important than, for example, the other subject was 1 credit. So in order to find the weighted mean, we are going to multiply every grade to its weight. So in this case, 4 times to the 3. So she took 4 from the first class was the 3 credits, right? So plus, she took 4 from the second grade with the credit 4. So plus 3 times its credit is equal to the 3, plus 2 times its credit is equal to the 3, plus 0 times its credit, which is equal to the 1. And everything should be divided to the number of the total credits per this semester, which is equal to the 3 plus 4 plus 3 plus 3 plus 0. So let's calculate this now. It is going to be equal to the 12 plus 16 plus 9 plus 6 plus 0. And everything divided to the 9 plus 4, it is equal to the 13. So if I'm just going to calculate this, it is going to be equal to the 28 plus 15 divided to the 13. It is equal to the 43 divided to the 13. And if you divide the 43 to the 13, we obtain 3.3. 3.3. This is her GPA. So this is how the GPA is calculated in the colleges or the universities. Well, in this lecture, we discuss about the 3 measurements of the central tendency. We talk about the mean, median, and the mode. The mean is more reliable, so it includes in its calculation all of the values of a sample, but it's not resistant to the outliers. So that is why sometimes we use the median in order to measure the central tendency. And the mode shows us the central tendency for the qualitative data. Well, thank you very much for your attention. I hope that this was helpful for you.